Customized brain training refers to the development of cognitive training methods that are tailored to the unique neural profile of an individual. It is based on the understanding that every brain exhibits distinct strengths, weaknesses, and patterns of activity. This approach leverages neuropsychological assessments to identify specific cognitive functions that can be enhanced. Tailored interventions aim to optimize learning strategies by focusing on these individual differences. Research in neuropsychology has revealed that targeted training can lead to measurable improvements in memory, attention, and problem-solving skills. Such personalized programs are designed to maximize the efficiency of cognitive processing and learning outcomes. By aligning training methods with individual brain profiles, educators and clinicians can create more effective learning environments. Overall, customized brain training represents a shift from one-size-fits-all approaches toward personalized cognitive enhancement. Example: a school implements individualized cognitive training programs after assessing each student's strengths and challenges, resulting in improved academic performance and faster learning curves. Analogy: it is like tailoring a suit to fit perfectly. Just as a custom-made suit conforms to your unique measurements, personalized brain training adapts to your individual cognitive blueprint. Brain profiles are comprehensive maps of an individual's cognitive functions, including memory, attention, processing speed, and executive function. These profiles are generated through neuropsychological assessments that use standardized tests and brain imaging techniques. The data collected provide insights into the neural mechanisms underlying learning and behavior. Assessments help identify cognitive strengths that can be leveraged and weaknesses that can be targeted for improvement. This detailed understanding of brain function is critical for designing effective, individualized training programs. Neuropsychological assessments allow for the identification of specific neural patterns and deficits. Such evaluations are the foundation upon which customized brain training strategies are built. They serve as both diagnostic and progress monitoring tools in the learning process. Example: clinicians use a battery of cognitive tests and functional MRI scans to develop a brain profile for a student, which then guides the design of a personalized learning program that focuses on enhancing attention and memory. Analogy: it is like having a full health checkup that includes a complete blood panel. Just as these tests reveal the unique condition of your body, neuropsychological assessments uncover the individual workings of your brain. Neuroplasticity is the brain's remarkable ability to reorganize and form new neural connections throughout life. It is a fundamental mechanism underlying learning and cognitive development. This adaptive capacity allows the brain to recover from injuries and adjust to new experiences. Customized brain training harnesses neuroplasticity by targeting specific neural pathways for enhancement. With repeated practice and targeted stimulation, neural circuits can be strengthened and optimized for better performance. Research shows that individuals who engage in tailored cognitive exercises demonstrate significant neuroplastic changes. These changes correlate with improvements in cognitive functions such as attention, memory, and problem solving. Ultimately, neuroplasticity is the cornerstone of personalized brain training, enabling lasting improvements in learning efficiency. Example: a middle-aged individual participates in a targeted memory training program and, over time, shows increased neural connectivity in the hippocampus, which is associated with enhanced memory performance. Analogy: it is like renovating a house where outdated structures are replaced with modern designs. Similarly, neuroplasticity allows the brain to upgrade its neural architecture to support better cognitive function. Tailoring cognitive training involves designing exercises and interventions that specifically address an individual's unique cognitive profile. This customization is based on detailed neuropsychological assessments that pinpoint areas of strength and weakness. By focusing on specific deficits, training can be more efficient and yield better outcomes. Personalized exercises are developed to challenge and strengthen targeted cognitive processes. This approach contrasts with generic training programs that apply the same regimen to everyone. Tailored training considers factors such as age, cognitive baseline, learning style, and personal goals. It incorporates adaptive algorithms that adjust difficulty levels in real time based on performance feedback. In essence, customizing cognitive training maximizes individual potential by aligning interventions with personal cognitive needs. Example, an educational app uses artificial intelligence to adjust its difficulty based on a student's performance, ensuring that each user receives exercises that are just challenging enough to promote growth without causing frustration. Analogy, it is like a personal trainer who designs workout routines specifically for you, taking into account your fitness level and goals to create the most effective exercise plan. A variety of techniques and tools are employed in customized brain training, ranging from computerized cognitive exercises to virtual reality environments. These tools are designed to engage specific cognitive functions, such as working memory, attention, and executive control. Many programs use interactive tasks that adapt to the user's performance in real time. Techniques include gamified learning, neurofeedback, and mindfulness exercises, all tailored to individual needs. The integration of digital technology allows for precise tracking of progress and continuous adjustment of training protocols. Data from these tools provide insights into the effectiveness of interventions and inform future training modifications. This dynamic feedback loop ensures that training remains aligned with the learner's evolving brain profile. Ultimately, these techniques and tools empower individuals to improve their cognitive skills in a personalized manner. Example, a cognitive training program uses a combination of interactive games and real-time neurofeedback to help users improve their attention span, with the system automatically adjusting challenges as the user progresses. Analogy, it is like using a smart fitness watch that not only tracks your exercise, but also provides personalized workout recommendations based on your heart rate and performance metrics. Neuroscientific research shows that targeted cognitive training can lead to significant improvements in focus and memory. Studies have demonstrated that specific training exercises can enhance the function of the prefrontal cortex, which is critical for attention and executive control. Likewise, the hippocampus, a key region for memory formation, can be strengthened through repeated cognitive stimulation. This improvement is associated with increased synaptic connectivity and more efficient neural signaling. Tailored brain training leverages these neural mechanisms to boost cognitive performance. The enhancement of these brain regions contributes to better information processing and retention. As a result, individuals experience improved learning outcomes and heightened cognitive clarity. Neuroscience thus provides a robust framework for understanding how customized training can lead to lasting cognitive benefits. Example, after engaging in a focused cognitive training regimen, students not only report increased concentration during studies, but also show improved performance in memory tests, correlating with enhanced prefrontal cortex activity on neuroimaging scans. Analogy, it is like upgrading a computer's processor and memory modules. The improved hardware enables faster processing and better performance, similar to how targeted brain training boosts mental capabilities. Emotional balance is intricately linked to cognitive performance, as stress and negative emotions can impair concentration and memory. Customized brain training programs often incorporate techniques to manage emotions, such as mindfulness and relaxation exercises. These practices help reduce the impact of stress on the brain, allowing cognitive functions to operate more efficiently. Neuropsychological research indicates that reducing stress hormones leads to better neural connectivity and improved cognitive outcomes. Emotional regulation supports the prefrontal cortex, which is essential for decision-making and focus. As individuals achieve greater emotional balance, they experience enhanced clarity and resilience in their learning processes. Tailoring training to include emotional management can lead to a more holistic improvement in cognitive performance. This integration underscores the importance of addressing both emotional and cognitive aspects to optimize learning. Example, a corporate training program combines cognitive exercises with mindfulness sessions, resulting in employees reporting not only improved focus and memory, but also reduced stress levels and better emotional balance at work. Analogy, it is like tuning both the engine and the suspension of a car. When both systems are optimized, the vehicle runs smoothly and efficiently, providing a more comfortable and effective performance. The impact of customized brain training is measured through a combination of behavioral assessments and neuroimaging techniques. Standardized tests can evaluate improvements in specific cognitive domains such as memory, attention, and processing speed. Neuroimaging methods such as functional MRI and EEG provide objective data on changes in brain structure and activity. These measurements help verify that targeted training protocols lead to neural adaptations associated with enhanced cognitive performance. Regular monitoring allows trainers to adjust interventions based on real-time progress. Longitudinal studies are crucial to understand the lasting effects of personalized training. The integration of multiple evaluation methods ensures that improvements are both quantifiable and meaningful. Ultimately, these metrics validate the effectiveness of tailored brain training approaches in optimizing learning strategies. Example: a study tracks participants over 6 months using both standardized cognitive tests and fMRI scans, and finds significant improvements in memory and attention, along with increased activation in key brain regions associated with these functions. Analogy: it is like regularly checking a car's performance through both a dashboard display and a comprehensive diagnostic tool to ensure that every upgrade is working as intended and delivering improved efficiency. Future directions in customized brain training are poised to integrate advanced technologies such as artificial intelligence and wearable devices. These innovations will allow for even more precise and real-time adjustments to cognitive training protocols. The integration of big data analytics will help refine individual brain profiles and predict optimal training regimens. Emerging research may further elucidate the relationship between specific cognitive exercises and neural changes over time. Customized brain training has the potential to transform educational systems, clinical interventions, and everyday cognitive enhancement. It could lead to widespread improvements in learning, mental health, and overall quality of life. As technology advances, personalized cognitive training may become accessible to a broader population. Ultimately, these developments promise to revolutionize how we approach learning and cognitive development on both individual and societal levels. Example: a future educational platform incorporates wearable sensors and AI-driven analytics to continuously tailor cognitive training exercises for students, resulting in highly personalized learning experiences that adapt in real time to each student's brain activity. Analogy: it is like upgrading from a traditional classroom to a fully interactive, smart learning environment, where every tool and resource is customized to suit the individual needs of each student, ensuring optimal growth and performance. The neuropsychology of learning is opening exciting new avenues for customizing brain training methods tailored to individual brain profiles. Imagine a scenario where your unique cognitive strengths and weaknesses guide a personalized training program, designed not only to boost memory and attention, but also to enhance problem solving and creativity. Advances in neuroimaging and cognitive neuroscience have revealed that every brain is wired a bit differently, and as a result, what works for one person may not be as effective for another. One striking development is the ability to use brain scans like fMRI or EEG to map individual neural activity and identify areas that could benefit most from targeted training. For instance, someone with a naturally strong visual spatial skill set but weaker executive function might see significant improvements if their training emphasizes planning and decision-making. This personalized approach raises an intriguing question: what if we could design brain training programs that adapt in real time to your brain's responses, constantly fine-tuning the exercises to maximize learning potential? The answer is gradually unfolding as researchers combine artificial intelligence with neurofeedback to create dynamic, responsive learning systems. Consider the example of tailored cognitive training apps that adjust difficulty based on user performance. These programs use algorithms to analyze patterns in your responses, ensuring that each challenge is just right, not too easy to be boring, yet not so hard that it becomes frustrating. Over time, this adaptive strategy can lead to measurable improvements in areas like working memory and processing speed. Remarkably, some studies have shown that personalized brain training can lead to lasting changes in brain connectivity, potentially enhancing overall cognitive flexibility. Could these improvements translate to better academic performance or even improved quality of life for those with cognitive impairments? The potential applications extend far beyond individual enhancement. In educational settings, customizing brain training could lead to innovative teaching methods that cater to each student's learning style. In clinical contexts, tailored cognitive exercises may become a critical part of rehabilitation for individuals recovering from brain injuries or managing conditions like ADHD and dementia. This integration of personalized neuropsychology and brain training invites us to rethink traditional one-size-fits-all approaches to learning and cognitive development. In summary, customizing brain training methods based on individual brain profiles represents a paradigm shift in how we approach learning. By leveraging cutting-edge neuroscience and adaptive technologies, we can develop training protocols that not only improve specific cognitive functions, but also foster a more holistic and enduring enhancement of mental capabilities. As research continues to evolve, one compelling question remains: how might these personalized strategies transform education and mental health care in the near future? The answers promise to redefine our understanding of learning and cognitive potential in profound ways.